Hello, ICS Math 10 students. Again, I am Mr. Sutton from Herron High School, and I will be leading you through skill 21A today. So hopefully you have something to write with as well as something to write on, whether it be a copy of the notes if you're able to print that, or just a scratch piece of paper so that you can follow along. Continuing our discussion on quadratic equations, today we're going to be writing quadratic equations. Uh, the parameters for creating an equation can be found in verbal descriptions, tables of numbers, or graphs. So here we have creating a quadratic equation from context. Quadratic equations are used in science and business situations. These formulas are represented with functions. So for example, we're going to look at an object in motion here. This is a general formula for a quadratic that is an object in motion. So this h of t, we want to write down what all these things mean. The h of t is the height of the object. T represents time. Okay, and G is the constant force of gravity. Which is negative 32 feet per second squared, or negative 9.8 meters per second squared. So depending on which unit you are in, you'll need to use either of these. V sub 0 is the initial velocity. So that's what that 0 here means. It means the velocity when time is at 0. And h sub 0 is the initial height. So that is what the 0 means here, the height when time equals 0. So down below we have this example. It says Ron throws a ball into the air with an initial velocity of 44 feet per second. The ball is 5 feet from the ground when he throws it. After a few seconds, the ball lands on the ground. Which function can be used to model the height of the ball Ron throws? So we want to identify our v sub 0, our h sub 0, and we need to know what g is as well. Are we talking about feet? Are we talking about meters? So I'm going to go ahead and pause the video. I'd like for you to pause the video as well and determine what these values are so we can determine which function over here is the correct function. So go ahead and try this one on your own. Pause the video and try this, please. All right, this is what you should have gotten. The initial velocity is 44 feet per second. The ball is 5 feet from the ground when he first throws it. 5 feet for the initial height. And since we are talking about feet, we will use negative 32 feet per second squared. So now we can plug those things into this formula here. So we do need to do 1/2 negative 32 t squared plus 44 t, and then plus the initial height, which is 5. So the only simplification we need to do here is 1/2 of negative 32, which is going to be negative 16. So it looks like B is our correct answer. Okay. Let's go ahead and take a look at the back of these notes. So here we have another example, another type of story problem where we're going to be solving quadratics, or writing quadratics rather. The bottom of a rectangular swimming pool has an area of 216 square feet. The length of the swimming pool is 6 feet longer than its width. The diagram shows these dimensions. What are all possible widths of the swimming pool? Show or explain how you determined your answer. So we know the area of a rectangle formula is area equals length times width. So now we just need to plug in these expressions that we know about the area, the length, and the width into this formula. So go ahead and come up with that. I want you to pause the video and write down how you can express the area equals the length times the width based off of what you're given in this diagram over here. Okay. Hopefully you are able to come up with something like this. We know the area is 216. We know the length is represented as x plus 6, and in the problem it says the length is 6 feet longer than the width. So the width we're just saying is x. We're defining the width as x and the length as whatever x is plus another 6. So my length is x plus 6. My width is just x. So from here, we can go ahead and start rearranging this to get it in standard quadratic form. I'm going to go ahead and distribute this x value to both terms inside the parentheses. I'm going to say 216 equals x squared plus 6x. I want to distribute x to this and x to the 6. And then we will need to subtract the 216 to one side. Again, we need to get everything on one side of the equation so that we can factor this and solve for x. I'm going to go ahead and rewrite this with the 0 on the right side because I think that's more how we're used to seeing quadratics, so we can factor. So now that I have my whole quadratic on the left side of the equation equal to 0, this is something that I can factor and solve for x so that we can determine what this width actually is. So we'll need to do an ACB tree here. So our A value is 1, our C value is negative 216. So 1 times negative 216 is just negative 216. And I need to find two values that multiply to negative 216 but add to 6. So I'm going to go ahead and pause the video here again. I would like for you to pause the video and see if you can come up with what these two numbers should be, two numbers that multiply to negative 216 and add to 6. Go ahead and think of those right now. Hopefully we were able to come up with 18 and negative 12. You should recognize that one of the numbers needs to be negative if we have a negative result here. Positive times a negative is the only way to get a negative result. And they need to be only 6 numbers apart. The difference has to be 6. So that is how we want to split up our middle term. So I'm going to say x squared plus 18x minus 12x minus 216 equals 0. And then from the first two terms here, I can pull out an x. We're left with x plus 18. From the second two terms here, I can pull out the negative 12. We're left with x plus 18 again. So our two factors are x minus 12 and x plus 18. Now to solve these for x, we set each factor equal to 0 and solve for x individually. So I need to add 12 to both sides, subtract 18 to both sides over here. And our two x values are going to be x equals a positive 12 and a negative 18. Now, Notice it says, what are all possible widths of the swimming pool? Show and explain how you determined your answer. So now we need to do some critical thinking here. Is 12 a possible width of the swimming pool? I would say yes. Width is 12. Is negative 18 a possible width of the swimming pool? I would say no. Width cannot be negative. So therefore it can't be negative 18. Okay, that is the end of this lesson. The next lesson we will continue using a different method of writing quadratic equations. If you have any questions about this, please see the information on the right-hand side about my office hours or Ms. Parsons' office hours and attend those links at the correct times. I hope you all are well and keeping up with your e-learning assignments, and I would like for you to have a good day.